All right, we're going to talk about algorithms with arrays. Remember, we've talked about this before. An algorithm is a process or set of rules to be followed in calculations or problem solving operations, especially by a computer. Basically, a list of steps or a known way of doing something. You know, people have studied this stuff for decades. And so we don't have to invent like the best way to sort some things, or we're not doing that today. But the things we are doing today, I'm just going to show you some ways that people do certain things, and you can make different ways to do it if you want, but these ways work. And it's part of computer science is to be given a problem. Like if somebody said, hey, find me the largest entry in this list, there's you shouldn't be thinking, wow, the largest entry, how do I do that? You'd be like, oh, I've done that before. And so here we're going to be doing that sort of thing today. So there's standard well-worn ways that people have figured out, so we don't have to reinvent the wheel. Here's a list of the algorithms the College Board wants you to know, and you'll have this slide deck. How to determine a maximum or a minimum value in an array. We did that last week, and we just did it today too. To compute a sum, average, or a mode in an array. A mode is the item that occurs the most number of times. We're not doing that right now. How to determine if at least one element has a particular property. Like if you hand somebody an array and say, tell me if if there's at least one test score in here above 99, Anyway, going down the list, access all consecutive pairs, like looking at items that are next to each other, and then checking if there's duplicates or not, reversing the order. Anyway, the ones that are all underlined, we're going to do all those things today. So I'm going to give you some examples. So checking for duplicates is one way to do it. If you know the data is sorted, you can just go and check every two elements and see if any two are the same. But we're assuming that our lists are not sorted. So you can't assume it's sorted for today. Here's an example of some code that would check for duplicates. So I'm starting with this line, integer array, ARR, and then I'm saying, imagine it got filled with a bunch of data. We didn't see that happen, but that's fine. Got a bunch of numbers in there. I'm setting this Boolean variable to false. It's called found dupe. That stands for found duplicate. And then look at this. I'm going from 0 all the way to the end in a for loop. And then I'm doing another for loop that starts one later and also going to the end. And it checks if these two entries are ever the same. So basically, we take the first entry, and then we check all the other entries. Is any other entry the same as the first entry? And then we go to the second entry, and we check, is that second entry the same as any other thing? So it's not very efficient, but it goes to the third, and then goes all the way to the end. So it's a loop inside of a loop, and if it ever finds one that's true, if it ever finds a duplicate, that's this, then it sets the variable to true, and then at the end, we just print true or false. Questions? Setting up a variable like this, we call this a flag variable. It's where like you're going to go into a loop and do some stuff. Before the loop starts, you could make a variable, set it to something, and then inside the loop, if you ever run into the situation you're looking for, you change that variable, and then after the loop, you can say, hey, did my variable change? It doesn't have to be a Boolean. It could be an integer value set to 0. Or even, and then every time you find the thing, you add 1 to that variable, and then you just check, is it still 0? If it's still 0 at the end, it means that you never found that thing. But anyway, a flag variable is what we use if we set a variable to some state, then we do a bunch of stuff, and then afterwards we check if the variable's changed. If you're in a method, you don't need a flag variable. You can just return true if you find a duplicate. So here's that same code, but done in a method. So this method, dupe checker, is receiving the integer array, and then we do the same thing with the 2 for loops. And if we ever find a duplicate, we just return true. And remember, in a method, that ends all execution of the method when you return. And then this return false down here, you have to have a way out. You can't. They don't let you make a method that leaves you hanging, so to speak. And so if all the looping is done and you never return true, then we return false. It means we didn't find a duplicate. You can look at this code later, and you're going to be asked to write code like that today. Reversing the order of an array might look like this if you used a method. Right here, this is public static string array, reverse array. So we're sending a string array called data, and we're going to return a new string array at the end where everything's in reverse order. I don't mean like hello written as ole, but the words in a different order. So right here, we're making a new temporary string array that's the same length as the one that got sent in. And then we did a for loop from 0 to the end for the first for loop. And we're setting every entry in temp to the one on the other end. So if there's 6 items in temp, we're setting, in data, we're setting item 0 here to number 5, and item 1 to number 4, and item 3, and so on. And then we return temp at the end. So this can be tricky, and I would like you to take time to, you're going to have to do it today. Don't just copy this code and put it in your code and not understand it. That would make the assignment go away, but it wouldn't help you on the test. I said here, the magic on this one is in this line right here. Notice I is going 0, 1, 2, 3, 4, 5, like that. And so we're setting the first item in temp, item 0, is going to be set to data, the last item. And the reason there's a -1 and a -I, think about it, if there's 1,000 items in data, the length is 1,000, but the last item is number 999. And this code would grab 999 minus 0, that entry, which is 999, and it would put it in the very first spot. And then when temp was 1, we'd end up with 998, and so on. And we're just taking the one from the end and putting it at the beginning of the other one. And then we return that reversed array. We're not changing the original array. You're not usually not supposed to do that. So I guess I drew a picture also. So we're taking the last element of data and making it the first element of temp. And then we're taking the second last of data and making it the second. And then third, dot, dot, dot. All right. Here's the same process, not using a method. It's the same thing. I'm not going to spend time. Here's the same process, not using a temporary array. So if I said, hey, I want you to just reverse this array, what you have to do, you can't, like, you want to make the first element equal to the last element, right? But you have to save the first element somewhere first. So what we're doing is we're saying, hey, here's a temporary variable num, and we're taking the first element and storing it there just for a second, kind of on the side. And then the next line replaces that first element with the last element. And then this third line replaces the last element with that temp variable. Because if you didn't set this first one aside, it'd be gone. Just take the last one, put it on the first, and then how do you get the first one and put it on the last if you didn't save a copy before? Anyway, and here's a funny one. You have to only go through half the array if you're doing it this way. Because if you go through the whole array, you end up reversing the whole thing, and then you reverse it back. Do you know what I'm saying? You'll do it. I did it. I was like, why is this code not working? And it's because I reversed the whole array, but then the code kept going and it put it all back again, which is you only want to do this method halfway through, because that takes care of it. Anyway, good times. Another thing I said that they want you to be able to do is access all consecutive pairs of elements. Like looking at 2 and then the next 2 and the next 2 and the next 2. Anyone know why we might want to do that ever in real life? You got a list of data? Here's reasons I could think of. You could check if the array is, you could check for duplicates if it was sorted. If two ever were next to each other and they were the same, then you found a duplicate. You could check if the data is sorted. You could be given a bunch of data and then you could say this is sorted, because if you checked every two and in all cases the first one was either less than or equal to the second one, that means it's sorted. You could also do something like, hey, tell me how many times the number 7 is followed by number 5. You know, anybody have any other thoughts? I can tell you guys are loving this. Here's code that accesses every pair, every set of consecutive elements. Notice I start here on item index 1. And that's because I have this -1 right here. So this is reporting if it finds 2 elements in a row that are the same. So if you didn't start, if you started at 0 here and then you tried to access I -1, that would go to -1, which would crash. So that's why we start with 1 here. You could start with 0, but then you have to do a plus over here. I think I even show you that right here. If you start with 0, you have to do a plus because you're checking the current one, comparing it with the next one. But you also have to do a -1 here because otherwise it'll crash when it gets to the end and tries to go too far. So, got an error here. No parentheses. Whew, glad I caught that. Okay, well, that's it. So now we got a lot of work today. Finish the warm up if you haven't, and then we have 6 practice REPLs. A, B, C, D, E, and F. Let me take a minute to remind you of 2 ways that you could get help if you need help. You can come to tutorial. That's a 3rd way. But on the AP Classroom, if you log in and go in there, I can actually make my screen pretend that I'm one of you. So I'm going to do that. And Michael, I'm going to be you. So this is what it looks like when Michael comes in, and probably all of you. And you can go over here to Unit 6. And let's see what shows up for Unit 6. There's array creation, traversing arrays, enhanced for loops, developing algorithms. Let's look at the algorithms. There's 3 algorithm videos. Let's look at one of them. In this video, we will demonstrate using the max-min algorithm with an array of primitive values. So here we go. This is awesome. The whole thing is 5 minutes long. So if you're like, God, I really don't understand what Mr. Hayes is doing, watch one of these videos. 5 minutes long, and you can pause it, and then you can open up a REPL and type in what they've got on the screen. And oh my gosh, listen, when I learned this stuff, I didn't have videos like this. I taught myself this stuff, and it was hard. And you guys have it. I don't mean that it's not. It is hard. It is hard material, but you got a lot of resources available to you. So any of those sections. And don't worry, Michael, I'm no longer acting as you on the AP Classroom. I don't think I'm able to press